Welcome back to Pizza Workshop. Well, my daughter's Volkswagen EOS broke down. The ECU fuse was blowing, 15 amp fuse. So my first step was to purchase the circuit diagrams, the schematics for that car, just to work out if there was anything else hanging off that same circuit that we might be able to eliminate, with the hope that it wasn't the ECU, it was something else causing that fuse to blow. That proved incorrect. There was nothing else on that circuit. I'll show you what that looks like. I'm going to show you exactly how I found the wiring for the ECU to confirm that there was nothing else hanging on that power supply. So what we're going to do is just open up this file here. So we've got EOS 2011 2-litre CCZB wiring diagrams. That's the one we're going to open up. So that's what this is here, this document. So this document is difficult to follow if you don't know exactly what you're looking for. Obviously, it's a huge document. There's hundreds of pages. We know that the fuse that was blowing was this one here. So this is a 15 amp fuse. So it was a blue 15 amp fuse, and this is the one that blew once, was replaced, and then blew again. So what I wanted to confirm is what hangs off that circuit. Right, so here we know this fuse is called SB13. So the next thing that we can do is go to the relevant section for our model of car to find this fuse 13. So for example, here we've got fuse 13, but it talks about a 30 amp or a 25 amp. Okay, so that's not the one that we want. So we need to scroll down and find the particular model. So here I've got fuse assignment for E-Box from November 2010. That is the one that we need. Now when we scroll down, we can see we've got fuse 13. It's a 15 amp fuse and it's for models with a petrol engine. Now what we want to look for is this SB13 circuit, and also this module number, so J623. So what we can then do is we can search for SB13. Of course, there's going to be a lot of hits for that in here as well. So we then need to find the relevant one that we're looking for. So we end up finding this one here, SB13, and it's on the module J271, which is the main relay, and SB13 is on the fuse holder. Okay, so now we know where the fuse is. What we want to do is follow where what's connected to that. So then I come across and I find this connector D182. So this solid dot means that there is multiple wires connected onto this point here. So it's a splice. So what I'm then going to do is put in D182. We're going to search for that. Of course, we find that one. The next one is in the list just below it. So here we were. There it is there. Now let's find the next one. And here it is here on this schematic. So now we can see we have 3 wires joined to that one wire from the other page, and they all go to J623, which is the ECU module. And there's nothing else on those wires. So we now know from fuse 13, it joins from 1 wire into 3, and it supplies the ECU, and there's nothing else hanging off that circuit. The other thing that we can see here is T94, and we've got pin 3, pin 5, and P6. So T94 is this connector. So if we go and have a look at that connector, this is exactly what we see on the ECU. And we've got pins 3, 5, and 6, which are the large pins on the ECU. And they are the ones that lead to that burnt out section of the track. So that is just a very quick overview of how to follow a Volkswagen diagram and how I determined there was nothing else on that circuit other than the ECU. That meant that the 15 amp fuse was blowing because of the ECU. Still doesn't explain why, and I still don't know exactly why. I'm hoping it's not some other external device that the ECU is driving. Apparently there's some talk about the oxygen sensors supplying power directly from the ECU, so therefore they're unfused. So I wanted to investigate further, and this is what I found. So this is the ECU out of the EOS. First thing I did when I pulled it off, I could smell through this vent that it's got burning electrical smell. Of course, then you want to inspect all of the pins. Everything looks okay with that. So we can see here too, it is an MED17.5. We've got the part numbers on there as well, the engine code, CCZB, and this hardware version as well. So that's that. Now I did want to try and open this up. Very, very difficult to get these off. If you're trying to do this, I would say heat up this really well around here. This is an aluminium case, so that will work quite well. But yeah, really just heat this up and get a nice sharp flat blade underneath, but don't go past this part of the case. Otherwise, there is a risk of damaging components. So as you can see, as soon as we take the lid off there, we've got huge burn marks on it. So unfortunately, there will be no fixing this ECU. And I was hoping to try and work out what may have caused it, but really it looks like basically between the main supply and ground, something has shorted out here. It's so much current, so much heat, it's actually delaminated the circuit board down there as well. So that is unfortunate. That means we can't clone this ECU either, because it will not power up. So what I've managed to do is purchase a same ECU, same part number, MED17.5 is the same as well. CCZB, same engine. However, the hardware version, this is H18. The one that failed was H17. So that was a little bit concerning. I'm not sure if that's going to cause me problems or not. But this all means I need to work out how to read the files out of the ECU. We've got to do the immobilizer remove function and then upload the files back to the ECU to make sure this will be able to start the car, keep the car running with the immobilizer functionality disabled. So that's the idea of all of this setup right now. So I purchased this quite a while ago in the hope that I might be able to use it for things like this in the future, but also DSG swaps as well. And it took me a little bit to work out how to use it and how to get the files. There is a lot of info on YouTube, but there's also a lot of misinformation, and there's also a lot of differences basically as well. Lots of different ways of doing things. So this is what they call the Scanmatic interface, and it's got the J2534, but it's called Scanmatic SM2 Pro, so that is a part of it. The Gardant dongle, so this is a hardware dongle that must be used in the PC. This is linked to the PCM Flash software. So I'll show you what I found out and how all that fits together. So this is a very old PC. The other thing that I was worried about was viruses, and also using this software that has been modified. I didn't want anything to access the internet. So I had this very old Windows 7 laptop that I wanted to use. I dug that out. I've removed basically everything off that doesn't need to be on there, and just to try and get it running easier, because it is very old and slow. So the first thing to do is let's plug. We've got USB cable here that connects to the SM2 Pro, so this needs to plug in. What I'll do first is just take the power, there is a power inlet for this device as well. So this powers the ECU, and it also powers the SM2 Pro as well. So I'm just going to push this in. So I've just connected this USB cable. We can see now that we have a red light on here. So the next thing that you're going to want to do is, once we connect external power, we'll notice that that light will change from red to green. So that shows that we have external power connected. Next thing I'll do is get the Gardant dongle and plug that in. That's connected and plugged in. I've already installed the drivers and things for those as well, so they've come up straight away and come up nicely. So now we can go ahead and open up this PCM Flash software. All right, now the biggest thing here is choosing the correct information or the correct device for the ECU that you have. So this was actually quite tricky, and I basically stumbled across this by watching people's videos. But for example, you can see this is MEDC17 that I've got selected right now. Well, that is not MED17.5. So that was a little bit confusing to start with. So for example, if I go back to where, you know, we look for Volkswagen Audi group, which is in here. So we've got a few of these devices in here from Audi. So there we go, Volkswagen Audi group US domestic USDS. So in here there is definitely MED17.5. But there's not one for a 2.0 TSI. So then when I come down here, here's a 2.0 TSI, and we don't have 17.5. So you can see the confusion, that just doesn't look quite right. So when I go down and look at others as well, so these ones, none of those are equivalent. So yeah, it's quite confusing when you start looking at those. There's all the transmission ones. If I go down a bit further here, we'll see that we do have,
I can't remember where it is now as well. Mercedes.
so anyway, here is where we look at Bosch MED17. So these are the ones that we need to use for this particular ECU. So we'll click on that. It's changed to Flash here. Now what we can do is go identification, because we want to make sure we have connection, and it asks us if we want to use this power line control. I'll select yes, and I'll tell you what that actually is in a second. So now on the Scanmatic, these LEDs light up to show that it's supplying power to the ECU. So I'm just going to click on identification again on here and show you what those LEDs do. So there's those LEDs that power up to say that it's supplying power to the ECU, and this one flashes to show that data is flowing. So now we can see we've had a successful read of the identification of that device. Okay, so that's the first step. Now we'll come back to that later when we do a full read of the data, but I just wanted to show you how I've wired this up. So this SM2 Pro has two power supplies. These ones here are the VAG. So this is the direct power supply that connects to what's coming in here. It also has these other ones, which is called VCC, okay, down here. Now these three lines are controlled by this device. So when it asked us, do we want to use power line control? That is where it actually turns the supply coming in on and off by itself. Okay, if you don't use that, then you can also use the main supply, but you'll actually have to connect the power and disconnect the power when it instructs you to do so. But other than that, the connections are very simple. So we've got CAN high and CAN low, and then we've got ground, of course, and then we've got these two GPT lines here. Now, apparently what these do is they actually pulse again from the Scanmatic Pro, will provide a pulsed output to these two wires, and that effectively triggers where the crank angle sensor connects to on the car, and also the cam position sensor. So what it's doing is it's fooling the ECU to thinking that the engine is running, and that is allowing us to get to certain data partitions inside of here to read the data that we need. Now, finding the correct pinouts was also a little bit of a challenge, but I did find, considering that I'm using PCM Flash, I looked up this, I looked up the ECU, so MED17.5, and this page shows us two different pinouts, one for a Skoda, one for Volkswagen Audi group. Of course, this is a Volkswagen, so this is the one that I used. So this tells us the power supply connections. So we got 5, 87, 92. It tells us the CAN high and CAN low pins, and also the GPT. Now notice that I have got two wires, and these are actually individually labeled as GPT0, and the brown one is GPT1. However, on this, it doesn't actually distinguish between GPT1 and 2. However, it does give us two pins to use for GPT. I figure it doesn't actually matter about which one these are connected to. Now then, of course, to find out which ones to connect them to, if you look in here, you can see where down the edge here, we can actually see the pin numbers are labeled down there as well. So we've got all the pin layouts, we've got the labels. It's not too difficult to find exactly where those wires need to go. But of course, we need to be super careful to make sure we're not putting power where it shouldn't be. So that is important, of course. All right, so now let's have a look at when we actually want to do a read. So we've done identification to confirm that we can communicate with the ECU. Now we're going to actually read the data out of the ECU. There's a lot of talk on the internet about P Flash and D Flash. This is not mentioned at all in PCM Flash. So here we actually have the Flash software and the EEPROM software. So we select EEPROM. I'm going to select read, and it's going to start communicating. It's going to ask us now, do we want to use automatic power line control? I'm going to go yes, and we can see the Scanmatic has powered up these VCC lines. It's powered up the ECU, and now it's reading data out of the ECU, and it asks us where we want to store that. So you can select wherever you like to store that. It will give it a date stamp and a time stamp, and it calls that TC1766 EEPROM. I'm going to click cancel because I've already done that. I just wanted to show you the process. Then we click on OK. So reading the EEPROM is very fast. I'll show you what it looks like now when we change from EEPROM to the actual Flash. Let's make sure I get the right one, and it is that top one. So now we go read again. It asks us for power line control. Yes, do it. And now this one takes much longer. So we'll let that go and come back in a minute or so. So while we're watching that load as well, I was quite concerned about the power supply that came with the kit being stable enough. But as you can see here, this is a voltage monitor in the top right. Ideally, I'd like this actually to be up around 13.8 volts. But I have tried it. When I first did it, I actually used this big supply here, which certainly did put the voltage up to 13.8. Now I've confirmed that all works, and now I'm just confirmed that this is the 12 volt 1 amp power supply, and it is definitely working reliably as well. So you need 12 volts, 1 amp, nice stable supply. And when that's finished, it wants to automatically name the file for you, again with a time and date stamp, which is good, and you can select wherever you want to save that. So I'm going to cancel because I've already done it. Click OK, and this automatically powers off the ECU and then goes into idle mode. Now the next step in this process is to modify the files to remove the immobilizer. So this program does exactly that. So this I bought off an eBay user, and this is how it works. So we click on that file first. Once that's come up, if I actually close that, then it pops up with the program itself, and this is exactly what we want. So what we do here is we want to load the EEPROM from the ECU. So we click on that, and then we can choose the original file, making sure that we choose the EEPROM. Now the way to recognize this is the EEPROM file is very small. So if we cruise over here, we'll have a look at the size of these files. So the very small one is the EEPROM file. So what I will do is select that EEPROM file and click on open, and this goes through, checks all of that data, removes the immobilizer stuff, and saves a new copy of the same file with the same name, but it calls it immo off, and checksum is okay. So once we've done that, we then come down to the flash file and click onto this flash file. So the flash file is the larger file. Let's just check on that to make sure we've got the right one. Yep, it's definitely the one, and it's the original file. So we click on open, and again this file is much larger, so it takes a much longer time, but we do have a progress bar on the bottom to show what it's doing as well. So we let that run. All right, and that finishes. It also automatically saves the file, and notice that it says please correct checksum prior to flashing it. Now this concerned me because I didn't know how to do that. Now the reason we don't need to worry about the checking the checksum is if we go back to PCM Flash, this is part of what PCM Flash does. So it will verify and fix CRC, which is checksum. So this is great news. So once we've completed that process, we're now in a position where we can actually go and upload these files. So again, we click on the right ECU, Flash. We want to select the file that we want. So in our case, we want to make sure that we have the file that is the one with the flash turned off. Okay. Now this is the large file as well. We'll look over here, we've got the large file. Okay, so that's the one that we want. We open it and we simply click on write, and then it will upload that to the ECU. Once that process is complete, we change it from flash to EEPROM, remembering that the EEPROM file is the small one. Immo off, we open that, and we simply write that file as well. So in that process, it will also fix and verify the CRCs, and everything should be okay. So now I can connect this ECU to the car. It should start and run, and we shouldn't have any issues with the immobilizer function.